Hello there, and welcome to Science for Sleeping. Tonight, we drift into one of the most mysterious ideas in all of science: time. The invisible rhythm that carries every moment away, quietly and endlessly. Time is not something we can see or touch, and yet it shapes every heartbeat, every sunrise, every thought that passes through our minds. So let your breath slow. Let your thoughts unwind. We're going to follow time, as if it were a soft river moving through the fabric of the universe. When you look at a clock, it seems that time moves at a steady pace. Seconds, minutes, hours, each one equal to the next. But in reality, time is not constant. It bends and stretches, depending on where you are and how fast you move. This strange truth was revealed by Albert Einstein more than a century ago. He discovered that space and time are not separate things. They are woven together into a single, flowing fabric, space-time. If you place a heavy object in that fabric, a star or a planet, it sinks slightly, curving the space around it. And because time and space are connected, that curve also bends time. The closer you are to a massive object, the slower time passes for you. Clocks on Earth tick just a little slower than clocks floating far out in space. The difference is tiny, but real. Astronauts who spend long months aboard the International Space Station return to Earth having aged a few milliseconds less than we have. They have literally traveled into the future by an almost invisible amount. Time, then, is not like the ticking of a metronome. It's more like the surface of an ocean, rippling, stretching, sometimes calm, sometimes distorted by gravity or motion. To move through time is to move through that ocean, carried by invisible currents. And just like waves, those currents can interfere with each other, creating strange effects that we are only beginning to understand. When scientists study particles that move close to the speed of light, they find that time for them slows down dramatically. To a particle called a muon, born high in the atmosphere, the journey to Earth should take longer than its brief life allows, and yet, because of time dilation, it survives long enough to reach the ground. Its own clock is running slower, stretched by its incredible speed. Time itself changes, depending on how you move. Far above us, satellites in orbit also experience time differently. GPS systems have to account for this. The clocks inside those satellites run a little faster than ours because they are farther from Earth's gravity. If engineers didn't correct for this, our navigation would drift miles off course each day. So every time your phone guides you to a cafe or a quiet road, it's because scientists have already accounted for Einstein's curved time. Pause for a moment. Imagine standing still, looking up at the stars, knowing that every tick of your watch depends on where you are in the universe. Every object, every planet, every person, each one moving through their own little stream of time. No two are perfectly the same. When the universe was born, in that first blinding moment we call the Big Bang, time itself began. Before that moment, there was no before. Time and space expanded together from a point smaller than an atom. And as they spread, they cooled, forming matter, stars, and eventually us. So when we ask, what happened before the Big Bang, we might be asking a question that has no meaning. There was no before. Time itself unfolded then, like a sheet being unrolled into existence. Over billions of years, that unfolding has continued. Galaxies drift apart, stars are born and die, planets circle in silence, all of it happening within this cosmic flow. And yet we still don't fully understand what time is. We can measure it, feel it, even manipulate it in equations, but we don't know why it flows forward and never backward. In physics, the laws of motion work perfectly well in reverse. If you filmed two billiard balls colliding and played it backward, the motion would look just as valid. Nothing in the equation says time must move forward. But in our world, broken cups don't reassemble, smoke doesn't return to the candle. The arrow of time points in only one direction. Scientists believe this has to do with entropy, the natural tendency of things to move from order to disorder. A deck of cards can be neatly stacked once, but when shuffled, it will never spontaneously sort itself again. The same is true for the universe. In the beginning, everything was in a state of low entropy, highly ordered, smooth, uniform. As time moves forward, entropy increases. The universe becomes more chaotic, more spread out. This one-way increase gives us the feeling of time's passage, the sense that moments slip irreversibly into the past. As you breathe slowly now, picture the entire cosmos, expanding, cooling, growing older. Each star burning its fuel, each atom vibrating slightly slower as the heat fades. Even the concept of a moment becomes vast and elastic, stretching across light years. To a distant galaxy, our entire lifetime is just a blink. And yet, in that blink, we feel an eternity. Time connects all of this, from the smallest particle to the largest galaxy, from the beat of your heart to the birth of the stars. And when you close your eyes and feel the weight of the present moment, you are touching that same flow, the same river that began when the universe did. Let your breath follow that rhythm, in and out. The same rhythm that stars follow when they burn and fade and return their light to the dark. This is the nature of time, not a clock on the wall, but a living pulse that moves through everything. Part 2. The flow within us. In the first part of our journey, we floated through the fabric of space-time, where stars bend the seconds and gravity can slow the ticking of the universe. Now we turn inward to the soft, private clock that lives inside every one of us, the rhythm of life itself quietly marking the flow of our days. Deep inside your brain, there is a cluster of just 20,000 neurons, no larger than a grain of rice. It sits in the hypothalamus, near the center of your head. Scientists call it the suprachiasmatic nucleus, or SCN. This tiny structure is the master clock of your body. It keeps time by responding to light, the rise of the sun, the fading of dusk, the color of the sky as night begins. Each morning, as light enters your eyes, it sends a signal straight to that cluster. It tells your body, wake up, the world has turned again. And at night, when the light fades, the signal quiets, allowing a gentle hormone called melatonin to flow through your bloodstream. It makes your eyelids heavy, your breathing slows, and your inner world begins to match the calm rotation of the planet itself. This is our circadian rhythm, a 24-hour pattern that connects us to the turning of Earth. Almost every living thing follows a similar rhythm. Plants, birds, even bacteria. It's one of the oldest patterns of life, older than our species, older than memory. When this rhythm drifts out of sync, from travel, stress, or sleepless nights, we feel disoriented. Jet lag is simply our body's clock refusing to accept that time has changed. For a few days, our internal rhythm is still ticking in the place we left behind. To the cells in your body, time is not a number. It's a feeling, a deep biological pulse, a sense of when to rest, when to wake, when to heal. As you listen now, you are not just hearing words in time, you are synchronizing with them. Each breath, each pause becomes part of your internal metronome. It's why lullabies work, why repetitive sounds like rain or waves calm the mind. They match the slow cycles already moving inside you. Your heartbeat, your breathing, the firing of neurons all have rhythm, and together they create what feels like the flow of now. This present moment where awareness lingers just long enough to feel alive before it slips away. But what is this present moment? If time is continuous, flowing like a river, then how does the mind create the illusion of stillness, of now? Neuroscientists have tried to measure it. Some estimate that consciousness updates itself every few tenths of a second. In that tiny window, your brain gathers sensory information, integrates it, and presents it as a seamless instant. Then it starts over again, like frames in a film, flickering quickly enough to appear continuous. You never really live in the present. You live a fraction of a second in the past, always catching up to what has already happened. And yet that delay, that microscopic lag, is what allows your mind to understand time at all. In dreams, the flow changes. You might live through hours of story in just a few minutes of real time. The brain, freed from external clocks, plays with rhythm like a musician. It compresses, stretches, repeats. Dream time is psychological, not physical. It obeys emotion rather than math. Moments of fear seem endless. Moments of joy vanish too soon. Even when awake, we experience this distortion. A pleasant conversation seems short. A line at the airport seems eternal. Our perception of time is not fixed. It's sculpted by attention, memory, and emotion. When you are deeply focused, you forget the seconds. When you are bored or lonely, they crawl. Psychologists call this subjective time, and it tells a different story from the one on the clock. The clock measures change in the world. You measure change within yourself. Every heartbeat, every thought is a marker of your own private chronology. When you recall a memory, the brain reconstructs it piece by piece. Images, sounds, emotions, smells. It doesn't replay the past, it rebuilds it, like the painter layering color on a blank canvas. That reconstruction takes place in the same neural circuits that sense the present, which means, in a very real way, memory and perception overlap. To remember is to travel in time, not through space, but through the landscape of your own mind. Some neuroscientists believe this ability to remember the past and imagine the future is the essence of consciousness itself. It's what lets us plan, regret, hope, and learn. Other animals may sense time's flow, but humans can see it as a dimension, a thing to move through in thought. That's why we tell stories, write histories, imagine what's next. We are creatures who dream forward even as we live in the irreversible now. Think of your earliest memory. Maybe a moment from childhood, filtered through the blur of years. The details are uncertain, but the feeling, the texture of that time remains. In recalling it, you bring that version of yourself into the present. Your mind folds space and time into one place, one consciousness. It's a gentle form of time travel, not through physics, but through awareness. As you lie here, listening, your brain is doing something similar. It stretches across seconds and sentences, building continuity where there is only a flow of sound. That sense of smoothness, of time flowing like water, is your mind at work, stitching the past, present, and future into a single thread of experience. When scientists scan the brain, they find that the default mode network, a group of regions active during daydreaming, lights up when we wander in thought. That wandering often takes us out of the present. We drift into memory or forward into possibility. It's a form of internal motion, the mind rehearsing its place in time. Meditation, by contrast, slows this motion. It trains the mind to stay within each breath, each sound, without slipping ahead or back. For many, this feels like stepping out of time entirely, a calm space where seconds lose their grip. In that stillness, time stops being something to chase. It becomes simply the rhythm of existence, quiet, balanced, infinite. When your body sleeps, the brain keeps its own schedule. It cycles through phases: light sleep, deep sleep, REM, each with its own frequency. Dreams bloom in rapid bursts. Memories are sorted, repaired, and stored. Neural circuits replay the day's events, turning short-term impressions into lasting traces. Time, even in rest, continues to weave. The boundary between waking and sleeping is one of time's gentlest illusions. We fall away from the day, and when we return, hours have passed. But to the sleeper, it's instant. Perhaps that's why sleep has always felt like a doorway to something timeless, a space where the body heals and the mind lets go of the linear. How Time Works, Part 3. The arrow of time, as physicists describe it, always moves forward, not because it must, but because the universe began in a state of extraordinary order. Since then, it has been unfolding, spreading energy, expanding, cooling, and diversifying. This spreading is what we call entropy. It is not chaos, but a measure of how many ways things can be arranged. When you drop an ice cube into a glass of warm water, the cube melts and the water cools. Entropy increases. You never see the reverse, where water spontaneously freezes around the cube. That is the quiet truth of time's direction. The universe prefers disorder, and that preference gives us the sensation of before and after. Pause for a moment. Imagine you are drifting above a frozen landscape. Snowflakes fall in silence, each one unique. Each moment in your life is like one of those flakes, formed, shaped, and gone. They never return, yet they build something beautiful together, a pattern that only exists once, in one direction. Entropy connects to the expansion of the universe. As space stretches, energy spreads thinner. Stars burn out, galaxies drift apart. Someday, far in the future, the night sky will no longer glitter as it does tonight. The light from distant galaxies will fade beyond the horizon of visibility. The cosmos will cool toward darkness as all the heat of existence evens out. Physicists call this distant destiny the heat death of the universe, a phrase both stark and strangely peaceful. A future where nothing happens because all things have already happened. And yet, this isn't a sad ending. It's an equilibrium, the universe's long exhale. It reminds us that even in vastness, stillness has meaning. For a fleeting moment, we are alive during a chapter of cosmic imbalance, where stars still shine, where time still moves. We are witnesses to motion itself. Now, return to your own time. The ticking of a clock is just one rhythm among billions. Your body, too, keeps time. The pulse in your wrist, the rise and fall of your breath, the gentle cycles of sleep and waking. Cells divide, memories form. Even as we rest, time continues its soft, invisible work. Every heartbeat marks another small chapter in the universe's long story. There's another way to view time, not as a river flowing past, but as a landscape already formed. In physics, this is called the block universe idea. Every event, past or future, already exists in a vast four-dimensional structure. To us, bound within it, time feels like motion. But in truth, perhaps we are moving across a still, infinite sculpture of existence, one where every moment is forever preserved. The laughter of a child, the dying light of a star, the breath you take right now, all etched into the structure of space-time. As you rest, you join an ancient rhythm that began before stars. Atoms in your body once danced in the heart of a sun. They cooled, became dust, became you. And they will move on again, someday, in forms yet unimagined. But for now, they are still. They are breathing. They are part of you, a momentary harmony in the song of time. Let your breathing slow. Let your thoughts loosen, like threads unraveling in warm water. There is no rush, no before or after, only the gentle unfolding of existence, the quiet pulse of the cosmos around you. You are here, in this instant, and this instant is infinite. Thank you for listening to Science for Sleeping. May your dreams drift softly through time, and may you wake as part of its endless wonder.